Welcome back to Chapter 2, Section 2, where we talk about how atomic theory evolved. We'll be starting with electrons, talking about how they were discovered and how we learned about them through the means of various experiments that were conducted in the late 19th and early 20th centuries. First up, we have J.J. Thomson and his cathode ray tubes. Now, electricity was discovered way before we discovered electrons. Obviously, people knew about lightning forever. Static electricity was well known, not just as lightning, but as, something you could play around with. It is named, actually, for electrum, which is another name for amber. Amber is a fossilized tree sap. You have amber with fur, and you can make a spark. So, electrum, electricity. Batteries, and their ability to store and transfer electricity using chemistry, was discovered and played around with in the 19th century, but people didn't really know what it was. And you can take a battery, hook it up to metal plates, have those plates in either end of a mostly empty glass tube. Not quite a vacuum, just a small amount of gas. You have a strong enough field in there, and you can get a ray, a beam, that gives off light. So here's the setup, the picture, so that you can see it. There's the cathode ray tube, glass tube, not quite a vacuum. And then you have your battery, and you have your cathode and your anode, your negative plate, your negative terminal, your positive terminal. And it sends a beam of electrons. Well, we now know they're electrons. They didn't know that. All they saw was this beam of light. And you can use electric fields and magnetic fields to make that beam bend, because the electrons in motion will respond to electric and magnetic fields. So that's what Thomson did. When he found that visible beam was deflected by those electric and magnetic fields, he knew that the beam was composed of solid material, particles that had mass. Because the wave being bended, it had to have a certain mass. But he couldn't determine that mass. All he could determine was that they were negatively charged, and that there had to be a certain ratio between the charge and the mass. Because more charge makes the beam bend more mass would make the beam bend less. So we could find the ratio between those two. What he could determine, definitely, was that the particles were small. Incredibly small. Very, very small. Smaller than the smallest atom, which is hydrogen. Like 2,000th almost, the size of a hydrogen atom. So he knew that what he had discovered was some kind of subatomic particle. Something smaller than the smallest atom. Something that was actually part of the atom. We now know that those were electrons. He didn't know them to be that. He didn't call them that. He called them corpuscles, which means tiny bodies. But he knew they were tiny, negatively charged, part of the atom. If atoms have subparticles, then they must have some kind of internal structure. That was one thing they knew, but they didn't yet know what that structure was. Another thing that they knew is that matter generally, and atoms in particular, are electrically neutral. They don't have charge. They're not attracted to nor repelled from electric fields. If electrons are negative, and they're coming out of the atoms, then the atom must have a positive charge as well, in order for it to be electrically neutral overall. And there must be some sort of structure, some way the atom is made up, where these positive and negative charges are arranged. Before we get to that, let's talk about Millikan and his oil drops. Here's the way the experiment was set up on the right. Over here on the left, we have basically a canister of oil. It has what's known as an atomizer. Okay, that's like the spray thing on top of a bottle of cleaning stuff, or at the top of a vial of perfume, whatever. It's just something to take a liquid and make it into a very, very fine spray, very small droplets. So he sprayed that into this chamber. And the chamber has an electric field, positive plate at the top, negative plate at the bottom. There's a tiny, tiny hole in that top plate. And oil droplets, very, very small, only very small, can fall through that hole. When they do, they get hit by an X-ray. The X-ray zaps it strongly enough to give negative charge to the oil droplets. So now we have oil droplets with charges falling down toward that bottom plate. But the bottom plate has a negative charge. So negatively charged oil droplets are going to be repelled by that plate. And that's how Millikan was able to determine what the charge on the electron was. Because he could actually measure the mass of the individual oil droplets, and he could measure the charge on the lower plate. So when the oil droplet was perfectly suspended, he knew that he was imparting equal and opposite charge sort of thing. So he found both the mass and the charge of the electron. Different derps had different charges, not a problem. Because when you look on the right, for example, just random sort of thing, those charges are all a multiple of a particular charge. 1.6 times 10 to the negative 19th coulombs. That's a very, very small number, and that's the charge on the individual electron. And because he knew the charge on the electron, and they knew the ratio of charge to mass, they knew the mass of the electron as well. So 1.602 times 10 to the negative 19th coulombs, charge on the electron, divided by the ratio that Thomson had already discovered, gave us the mass of the electron, 9.107 times 10 to the negative 31st kilograms, an incredibly small number. And that's how we discovered the electron, its charge, and its mass. The cathode ray tube and the oil drop. And that's why they came up with the plum pudding model. Plum pudding is a British dessert, pictured to the right. It's kind of like a pie without a crust. A lot of pies have a sort of gooey, sweet matrix to hold together, other stuff that you put in it or on it. So the atom as a whole is the entire pudding. And the electrons are studied inside the atom like plums, raisins actually, studied inside the pudding. The electrons, the negative plums, are inside the pudding. The pudding itself is a positive matrix, and the whole thing is neutral. Now, the thing is, the plum pudding model, it was wrong. But, give them a break. They were working in the dark. It was a good stab. Good effort. So that is how we discovered the electron and some of its properties. Negative charge, negative 1.602 times 10 to the negative 19th coulombs, in fact. And a mass, 9.107 times 10 to the negative 31st kilograms. And the fact that the atom has some kind of internal structure. They didn't know what it was. They were working on it.